Good evening, and welcome to Rubber Duck Engineering. I am Eric Seidel. This is Adam Barth.
Hi, Eric.
And tonight we're going to be talking about fuzzing. We're going to fuzz our Wren VM written in Rust and see how far we get. So, hello, Adam.
Hey, Eric. How's it going?
It's going pretty well. It's been a good week. How about yourself?
It's been pretty good. It's been no meetings week at work.
Good times.
Yeah, I spent a lot of times like staring and pounding out code, which has been a lot of fun. And people have secretly been scheduling meetings with me. And I had 2 meetings one day, and they tried to schedule on top of each other. It sounds like it's no meetings week. I think we can figure this out.
Yeah, my job is kind of to sit in meetings, so I still had meetings even though no meetings week. But so yeah, tonight we're gonna do fuzzing.
I'm so excited about fuzzing. Like for so long, fuzzing has been this undiscovered country that like you needed to be like inducted into the secret fuzzing society to like know how to do it. But like at least what you've been telling me, like the tools have come a long way since then.
Oh my, yeah, it's so far from whatever 18 years ago or whatever I was first introduced to fuzzing. It's just night and day. There's no secret handshake. There's like common libraries. I went searching for fuzzing tools because I wanted to learn what was the modern. Turns out Google's written a lot of them, which doesn't shock me because there's a big fuzzing and security culture there. Hey Giffy, nice to see you. But yeah, there's a whole bunch of fuzzing tools, and some of them are easy to use.
Give a brief introduction. Like what is fuzzing for those of us who don't know?
Fuzzing is just throwing random stuff at your program, not entirely random, but just junk at your program to see if it crashes. It's a little more sophisticated than that, but you're sort of exploring the input space to try and find things that a malicious actor might want to use to break your program or just to find error cases. And it's generally used. Go ahead, sorry.
I think the name comes from the fact that you like have a sharp input that you like typed in yourself as like a test case you wrote, and then you sort of jiggle it around a little bit and then see what happens. Oh, hi, maybe Hal9000. Thanks for stopping by.
Yeah, nice to see you. Yeah, well, I think there's a bunch of ways to sort of like seed the fuzzer. Like sometimes you can start with a corpus of tests and just like mush them all together or whatever, or iterate them. But yeah, it's for things like, say you wanted to write something that talked to the network, right? Or used untrusted user data. You want to understand, like you also use fuzzing some for UI frameworks. Like I know there's a fuzzer effectively for Android that like is a monkey, I think they call it monkey test or something. Anyways, it just taps random stuff to see what happens. And then often you find crashes and you go and fix the crashes.
Yeah, I remember when we first unleashed that thing on Flutter, it found all these like cases we never thought of. Like, what happens if you click the button immediately after the transition begins, and the button just like freaks out? It like cannot handle this.
Oh, you're talking about the monkey test. Yeah. But yeah, fuzzing is big in the web browser space, particularly because the web is a big space, and when you have trillions of web pages, one of them is going to find that crash.
Or someone malicious is going to look for it and like craft the perfect input.
Yeah.
So what fuzz are we going to be looking at today?
So I looked around at a few. It turns out there's this OSS fuzz, which I don't think I'd heard of because it came out of Google, I don't know, 10 years ago or something. But it turns out Google will fuzz your program, your open source program. You can just go to this OSS-fuzz. And
OSS is open source software.
Yeah, it's open source software. And you like commit a configuration file to explain to their presumably cluster of fuzzers how to fuzz your program, and then it'll just fuzz your program on a regular basis, which is cool. But we are actually using, because we're using Rust. Rust has a crate for this, and so
there's a crate for that.
There's a crate for that. So Rust has a crate for that, which sits on top of Clang. So Clang has been this great project in the open source to like have a place to pour all the compiler energy of late. But a new place that wasn't GCC. And as part of that, they have like a sanitizer library and a fuzzing library that I think is relatively new because I like have to use nightly builds to use it. And Rust has integrated it. another level of technical excellence from when you and I used to do this is that you would separately have to get the thing that like turned your malloc allocator into something that like guarded, its edges or whatever, and then separately turn on a fuzzer, or maybe you write your own fuzzer. And now the whole system just does all that for you. In fact, I was trying to get the fuzzer to work. I haven't actually gotten it fully working, but we're going to get that happening tonight. I was trying to get it to work, and it kept running into leaks because we have a ref counted program in Wren, and of course there's cycles.
Because it's meant to be garbage collected. We just haven't implemented the garbage collector yet.
Yeah, we'll get to that. And the cycles prevent or create leaks. And so with those leaks,
the fuzzer just like fills up memory like as fast as it can.
Well, the fuzzer correctly treats a leak as a crash because leaks are crashes.
Oh, interesting.
I mean, leaks are crashes. They're just slow crashes, right?
Oh, okay. So it like has a leak detector built into it that like flags says, "Hey, you leaked." That's cool.
Let's see. Maybe Hal says there was a new paper released for fuzzing playtesting of games. What?
Oh,
that's blowing my mind.
That sounds like maybe a similar idea for the UI framework fuzzing. Like maybe like try mashing the buttons on your game and see what happens.
Yeah. Well, I think a lot of games should be fuzzed. I played a game recently, and I rage quit like, I don't know, an hour in because I kept like walking through the walls, like in the corners or whatever, and then eventually I walked through one and I fell, and then restarted me back at the beginning of the game. I was like, okay, I'm done.
That reminds me of all those like speedrunners of those classic games who like know exactly how to like walk through the wall in just the right way to get to the final boss room or whatever.
Well, I've shared this theory with you before, but there's this interesting overlap between the speedrunning community and the exploit community.
Yeah, they're both trying to craft that perfect input that gets the program to do something really unexpected.
Yes. And I wonder if there's a career path where you just like hire, because there's also the speedrunning community is subsets into two sections, probably more than that, but one of which are like the people who find the exploits, and the other of which are the ones who mash them like 5,000 times and get really good at using them.
Like the innovators and the executors.
And both of those like have a place in like the security community, and I wonder if like this is like a missing hiring pipeline for the security community.
Maybe has another message.
It discovers the paths which players might take to escape levels. Oh,
that makes sense.
Okay. Yeah. So shall we do the code machine?
Let's do it. So you don't quite have this working, which is going to be an adventure to see if we can actually get it working well.
Yeah, it's always a risk to do these things live. So what I don't have working, so I let me give you a little bit of a tour. So there's this cargo fuzz thing that you install.
Mm-hmm. And it's just like a crate or like a command you install into cargo.
Well, it's interesting. It appears that cargo does the same thing that Git does, which is that Git, you can extend it by adding things to your path that have these dashes in them.
Mm-hmm.
So the way that like git diff works is it's just a separate command, and the git command, whenever it wants to like tab complete out, it's just like, oh, I'll go find all the dash things. I think cargo is doing the same thing. Cargo dash.
Oh, I see.
So
cargo
like
dash fuzz.
This cargo fuzz thing was like some separate Rust program that installed itself as a program in my command line, and then cargo like knew how to use it.
That's pretty neat.
It's a neat extensibility trick, and I think more programs should use it. But so this cargo fuzz thing, which I can't type. What if we do like it'll like set up your project. It'll add these little like fuzz targets, which are over here. It has this fuzz directory, and it creates a dummy fuzz target, which I've filled in some. And then it has the ability to like just run it. You just go run. You can list the fuzzing targets, and then when it finds one, you can like minify it if you need to.
Oh, I remember that being a very important step. And I've seen fuzzer output before. Just like this huge pile of garbage. Like this thing crashes your program.
Oh, yeah.
And you're like, cool. What is this?
Well, and again, going back to
like really well, they can like minify to like here's like the one line thing that crashes your program, and that's so much more useful.
Back in the old days when you and I used to walk uphill both ways to school in the snow. It was like a separate program you had to go find and learn how to write.
Actually, I think the corpus minification I think might be slightly different. I think this is if you generate a large corpus,
tmin.
What's that?
There's tmin rather than cmin. I just highlighted the wrong one.
Oh, I see.
Tmin is what I mean. It minifies a test case.
Yeah. Okay. Cool. That makes sense.
But so if we run it, it'll actually fail
out. Can we see the fuzz target? I think we got a preview of it up here.
So this is the fuzz target. This is the whole thing. It's like I will spit in random data to you after I set up Rust in a mode where it's like memory is safe and guarded and it's detecting leaks and all the other things that I want set up. And then I will just spew data at you. You implement a function to do something with that data.
And you decide to run the whole interpreter as opposed to like say the parser or some piece of it.
It's true. And maybe that's what we should do instead tonight is like just run that's a really good idea is that we could just like run the lexer and just fuzz the lexer.
Do you want to start there? Like I've had success doing that because often you'll find bugs and in the early stages of your program, and then you can work those all out in those fuzzers and then move on to the more deeper, complicated behaviors of the system.
Yeah. So like we could just do that where we, so I have to look at this. So another one of the, because again, I make progress, on the weekends here. I made some progress on the weekends. One of the things I most recently did was I split Wren test, which is the thing that sits on top of the API. And this is an analog to Wren test in Wren C. And then I have my own separate Wren debug, which claws into the innards. And we'll do more things. And eventually this will get guarded away in some way that it's not exposed in public API. But so this is the thing where you, so like if we do print tokens, for example, where is it? It's going to be here. Print tokens just does this basically. Let's see. Oh, not working. Oh, okay. So we don't have the Rust analyzer tonight because I switched to the nightly configuration of Rust, and that made the analyzer sad. So we'll
have to use search and replace instead of fancy
and we're probably not going to get warnings. So without running things, so it's fine. We'll roll with it here. But so we're going to need to do like this. We actually have it from bytes. So we're going to need, we still need the VM. Let input equal that. And then we're going to go back to this thing and we're going to want, remember, because we can't jump around anymore, we have to do it manually. We're going to go down to our fancy Lex thing.
It's always so amazing to me, like when you're used to using these analyzers and this like really smart ID integration, that when it gets like the rug pulled out from under you, you don't have it. It's like you so miss the feel of it. And like I've never had that in C++, and like I think that's part of the reason all these high tech languages feel so much more powerful to me is they have so much better tooling.
And I've come to even further appreciate Rust. What was it? Oh, it was just like switching to the nightly channel. It was so simple. There's also some crazy
the analyzer, but it was simple.
Well, yeah. And I probably could have debugged that if I had not discovered it 2 minutes before we went live. This was part of our technical difficulties, by the way, while we were late tonight. But the other crazy thing that's going on right now is that we are looking at Linux running on Windows. We are using the WSL.
Oh, you transported to WSL land?
I did, because the fuzzer needs Linux for the memory safety tools. It doesn't work on Windows yet. Again, we're using relatively bleeding edge either Clang stuff or Rust stuff. I can't tell, or I haven't looked enough.
Or all the above. Bleeding edge Windows, bleeding edge Clang, bleeding edge Rust.
So I think that maybe we need to make a second fuzz target. I don't actually know. Fuzz targets, fuzz target 1, fuzz targets, fuzz target 2.rs. Oh, hello. So then if we open this thing, we got to close this again. So this thing that we just wrote.
I think this lets us keep both of them around.
And so this is actually then probably not. This is like run use. Oh, I just imported everything anyways. So this might work. We don't have the analyzer to tell us. Flying a little blind. Run, and then I think we need to
just like select a fuzz target or something. Oh, you can tell it like that. That makes sense.
Like this. Fuzz target 1 failed to build cargo build.
Maybe just try to cargo build it because we don't have the analyzer to tell us when we messed up.
Also possible we have to tell fuzz.
Oh, like in the cargo file somehow, or?
Yeah, it's also possible we can just edit the first one too. We need fuzz target 1. Well, let's list our fuzz targets. Okay. Another thing we could do.
Why don't we just put it in fuzz target 1 for now? I'm sure there's a way of registering it.
Yeah, I'm sure there is too. But let's just move this. Just comment that out for now. Okay. Doing it live, as they say.
Yeah, that's the fun of it.
Let's target 1. Okay.
Semicolons.
Oh yeah.
This may be slow without the analyzer. Getting the rest errors one at a time.
It could not compile. Use of undeclared. So why is this? I think this is use of Wren Rust, Wren debug. Should do it. Unused imports.
Yeah, I guess it wasn't quite there.
Private function, that's fine. That I can handle. And this is in Wren debug. Okay. So we want this. Wow, really lack of analyze is going to make.
Oh, you know what? If you put the star back in there, it'll be fine. You just have to, that line 6 that it's complaining about, you just have to pub use it, and that has both Lex and input manager for you.
I see. So what's happening is the star is importing everything that's public, and thus it's just not even
Correct. And when you ask for Lex specifically, it's like, oh, I saw Lex was there, but you can't have it.
Well, I don't think it actually even sees it, quote unquote. Like it's later in the pipeline that and it's probably a hack. But all this stuff is a hack, but whatever. Rolling with it. Compile in module. Yep. What?
You just split it into 2 different lines.
It's telling me that compile in module is not public. Oh, it's looking like it's going to work.
It's thinking real hard.
It is thinking real hard. It's remarkable that just the performance differences between all these tools on Windows and all these tools on Linux inside Windows. I wouldn't say that they're universally faster or slower, but the performance characteristics just feel different. Okay, what does it say? Unknown field.
Oh, you got a steer.
Yeah. This is because this was being used in a context where that was different. Source. Input from string. Yeah, that looks right.
Maybe it's like a 2 owned. Like you're giving it a slice, and it's wanting an owned version. Do you have a from stir?
I have a from bytes, but that won't have done the UTF-8, and then we'll really find crashes, which maybe is the point. into will do this. Can't borrow is mutable.
It's just so slow. It's not the analyzer. It's. I'm feeling your pain here.
Oh, okay. So here we go.
Oh, it crashed. It found something.
Well, let's see. Running with
Okay.
entropic power schedule. Whatever that
Oh, the
means.
entropic power schedule. Those are my favorite power schedules.
255 files. Okay.
Okay.
Max length. Fuzzer will not guarantee inputs. Okay. Thread unnamed. Panicked. Oh, this is our borrow stuff.
What
Okay.
is this?
So this is. Remember how I was saying about how our GC. I was working on this is the bug that I mean we could try and fix this, but this is the bug that if I comment that out, it's going to start leaking. So we're going to get back to leaking again.
Okay, so let's fix the leaks. So
I think the best way to look at this is for us to just try running something.
just regular run, not.
Cargo run. I mean, let's just cargo run something. So I'm trying to just run everything to like find where the thing dies.
So just to give context, you had previously tried to fuzz things. You found this leak problem, and you were trying to get rid of the leaks in the system so that you could then fuzz it.
Correct. So setting this up last night, I got the fuzzer stuff all working, but then the very first thing that it noticed was that we were leaking everything. Because as I said at the top of the show, leaks are crashes. They're just slow crashes.
And so what is your solution for leaking things? Or
what is it?
How are you approaching the problem of fixing the leaks?
So I made it so that whenever the VM shuts down, it crawls it crawls all the stuff it can see and tells it to let go. Right? Because right now, like there's just some obvious cycles. It was leaking thousands of objects initially, but there's obvious cycles of where like the functions have a pointer back to their module, and the module, of course, also knows the functions that are declared. And so, like,
I see.
And similarly, the class hierarchy, all bottoms out at one class, and there's like an intentional cycle between object and class. Mm-hmm. So you just have to break the cycles. But
so it looks like all the tests pass. So maybe.
So I wonder.
I'm just curious if we should look at the place that the fuzzer pointed us to as a problem.
Well, I actually want to turn on backtrace. Like, hello. We'll look at this, but I think in order to see where because this is going to be like trying to mutably borrow a class, while earlier in the call stack, we've also mutably borrowed that class.
I see. There's like a runtime check on the reference cell or whatever.
Yes. So, like, and if I suspect we look at the test case, it has like a single character or something, I bet. So this is not telling us, but Rust backtrace will tell us. So if we look at this, this is the problem. We're calling clear class, but we don't know what we're calling it on. And clear class is the thing that tells the class to drop its pointers.
I see. And the lexer is already instantiating classes in the system.
It's the VM that's tearing this all down, because you init the VM and that loads in part of Wren core.
I see.
The lexer is somewhat late in the. You have to actually have the whole system working to get to the lexer in the first place.
Can we turn that off and just have the lexer lex?
Oh, you're right, because the lexer doesn't actually take the VM as input, does it? Oh,
right.
There you go. Yes. I'm forgetting that I had designed we're going back to very old technology. This is like I probably haven't touched the Lexer in weeks. There you go.
Okay, so now it's like trying lots of different inputs and looking for something. This is the podcast of watching paint dry, like watching random numbers be thrown into Lexer.
Yeah, I mean, we've not been here before, so we don't know. But I know that this thing has options about like running it with multiple threads and stuff like that.
I mean, the dream of writing things like a Lexer in Rust is that you don't have like vulnerabilities or crashes, right? Like that's kind of why you pick this kind of technology.
I mean, this is a really good sign. Like I remember when we wrote some of the first just primitive fuzzing like Python scripts, or maybe they were Perl scripts at the time.
Oh, usually the first time you run a fuzzer like against a C++ program, like it instantaneously finds.
Oh yeah. And so the fact that I mean, what is this? We're 100 and is that 1 million seeds in? Am I reading that right? Are those seed numbers, or I just don't even know. I actually wish I understood what this was telling me.
Should we stop it and could we look at some of the inputs it is using to sort of see if they're like, I can't tell whether it's just like trying random things that are useless or whether.
Well, it's telling us like it's modifications that it's making over here. And is this like how fast it's going?
Yeah, 4,000 executions per second, I think is what it's doing.
Okay. Could be fun to actually profile this. But yeah, I mean,
can we look at the corpus? Like, I noticed there was a corpus directory in the fuzz directory. I'm just curious, like, what it's feeding us.
I have no idea. I mean, this looks like fuzzed input.
Return a lot. Some crazy ass number parsing.
This is really good. I wonder how they seed this. Like, this is way better than I expected.
Whoa. These don't look like real programs, but they're like, you can recognize some of the.
Like, where is it getting this? Is it getting this from like strings in the program?
So my understanding of the way libFuzzer works is it has a profiler integrated. And so it's tries an input and then sees a branch where that input goes down. And then we'll pick the first branch and try to like invert that condition and edit the input to go down the other branch. And then generally explore your program that way.
We are living in the future, man.
Yeah, it's really awesome technology. And the fact that it's like push button usable is like so.
It's so cool. Like, I really think that most people who ever view this show will never in their life encounter like a reason to use a fuzzer. Maybe I'm being over the dramatic.
I disagree. Like, I think a fuzzer should be part of the regular toolkit that everybody uses, like unit testing and code review. And like, it's just like an engineering best practice. Like,
I guess.
You
and
have to get to
makes it so simple.
Yeah, you have to get to the state of your project where it's the right thing to do. Like, just like you don't like the first thing you write is not necessarily a code reviewed unit test for your program. Usually, you're like hacking a little bit to get a prototype, and then you're like, okay, this prototype is promising. Let me start going. And that's what I think is cool about this Wren project is like because we've been doing this for a number of weeks, we've gotten deep enough into it that like, okay, now is the appropriate time to apply fuzzing to it.
Mm-hmm. Yeah, I mean, it's actually a little early still. Like the fact that I had to like make it not leak the world in order to make the fuzzer work would suggest.
Those are sort of assuming a higher level of correctness that I think you've aimed for so far.
Yeah, but I like your suggestion to move back to the Lexer. I think that and clearly, like it failed to bring down the Lexer with 1 million test cases or whatever it went through.
Do you want to try introducing a bug to the Lexer and see if it can find it? Because it's possible that your Lexer doesn't have any crashes in it, right? Like, it's kind of the purpose of using Rust and type checking things.
Mm-hmm. It's funny actually. There's Rust bindings for the original Wren. Not to speak poorly of it, but it is written in C. And they talk about how like they try and validate inputs, but like you will get this thing to crash. Like the Rust bindings for the original Wren like warn you as a Rust user that like this stuff is unsafe.
Well, the expectation when you use a Rust package is that it's safe Rust that isn't gonna like have any memory errors or things, right? That's
okay. So we were going to introduce a bug in the Lexer and just see if it can find it.
I mean, it's also possible you have bugs. Like I'm not trying to say your code is perfect. I'm just.
Oh, I'm sure. How obvious? Just want it to crash?
Let's go into next token and see, do something in there. You're laughing. Can you?
I'm just laughing about that. I have to like search manually.
Oh, the analyzers there.
Pardon me while I pull out my bearskins and and rocks here. Yeah, I don't have a working analyzer.
Pick one of these cases and put like a cert in it.
Yeah. Will you get to fields? Panic. Found me. Now the analyzer would be telling me this is all dead code, but it's not here to tell me that.
The compiler may tell you.
The compiler will tell me quite loudly.
I actually find the dead code thing really annoying when I'm just like, this compiler immediately says, no, what are you doing here? Sometimes I just want it to compile. Like, I know it's dead code. I'm just playing around compiler. Like, chill out. It's going to be cool.
Well, and it's actually, so the Visual Studio Code integration for Rust could be infinitely better. Not infinitely better, but a lot better. And one of the, there we go. It found it immediately.
Okay. That was very fast.
Well, again, it's doing like 1 million inputs a second. There you go.
You found it. Can we look at the input? Like, I'm just curious, like, what the input looks like.
Reproduce with.
Let's minimize. Oh, can we look at it unminimized and then minimize?
So if we look at. I'm so lost now. In this like bath of warnings.
I think part of it is that the project I'm working on has warnings as errors turned on. So any like warning anywhere will be like, nope, I'm not going to file your whole thing until you make it perfect. That's the input.
Underbar.
It found it.
It found it and it reduced it. I don't know whether it reduced it or not. But it's true. Any underbar was going to crash the program.
Okay. Should we put a like more subtle bug in?
Well, I was thinking if I couldn't get the fuzzing of the big thing to work, like an example that we could use is we could just take the input and we could like sum it up and modulo it some number.
Well, let's do that, but let's do it deep inside the Lexer.
I see. To see how.
Like, what is toChar token? What does that function do?
Oh, this thing. This thing says it's.
Fine. Let's go look at it and see if we can mess it up a little bit. It's TWO. I mean, we're kind of playing now because it didn't find any real bugs. Like it didn't like.
It's really helpful to have a second pair of eyes, by the way, when you're programming. So this
also like, it's useful to have a rubber duck to help you engineer. Buy your t-shirts now.
So it looks at the next input and sees if it matches the one that we expect is the second byte. If so, it returns the 2 token variant. Otherwise, it returns the 1 token variant. Right. So it's saying it's like for equals versus double equals. It's like, do you see a second equals? If so, return that. Otherwise.
Okay, so maybe
so if we crash here, it will have to have found 2.
Yeah, okay. Sure. Why don't you crash here if the second, yeah. Do we take out the other panic? So we don't find that one right away.
I'm pretty sure we did. It'll also yell at us again. Oh, it's at us. Okay. We took out the other panic. Is the TLDR.
Because it didn't warn us that the rest of the whole Lexer was unreachable.
Yes. I wonder why it's taking so long, this like last little step.
It just found it immediately.
I mean,
okay, well, like, can we look at the input?
I think we are proving that these fuzzers work.
Okay. So, I mean, from this makes me think that when we don't have these artificial bugs, that maybe your Elixir doesn't have a problem, or at least if it has a problem, maybe it's pretty deep.
I would not expect the Elixir to have any problems. I mean,
well, if I'd written the Elixir in C++, I would expect it to have problems. Okay.
Well, as an example from Rust, I think I may have said this a few episodes ago. Like, I intentionally did not ever touch the unsafe keyword. Mm-hmm. The one day that we did, I have since found 2 bugs in that single line of unsafe keyword.
Can you show us that code, actually? I think that would be interesting to talk about. It's a little bit of a detour from fuzzing, but I think, like what you brought up, I think it's quite interesting.
Unsafe.
So, let me try to restate the problem that I think you're trying to solve. So, in Wren, there are hash maps,
mm-hmm.
and you can key your hash map with a float.
Mm-hmm.
But Rust doesn't think that's a good idea. You can't key your Rust hash map with a float, because comparing floats for quality is kind of nonsense because of nans and like denormalized
in fact, I have a test
floats.
Case. So when I finally fixed it, I wrote a test case,
mm-hmm.
and you will see here one that doesn't make any sense. But I assert that it doesn't make any sense. So assert not equals that 0.3 when hashed is not the same as 0.1 plus 0.2.
That's a precision thing. Like, just that somehow one of these numbers is not perfectly representable. Like, is 0.3 not perfectly representable or something?
I think it's 0.2, but okay. I don't remember. But yes.
But that's just the tip of the iceberg with floats, because there are also nans totally. Where like the same bit pattern just does not equal the other thing of the same bit pattern.
Yeah,
it's like it's a nan of a certain kind. It's like
yep.
But anyway,
so equality for floats is bonkers.
So that was the problem. Like, okay, how do I key this? How do I take this API contract that says Wren can key hash maps with floats and back it with a hash map that doesn't take floats as keys?
Well, and so what actually the problem was, which I in part worked or in part fixed by adding this little helper function, I also needed to use the second time, but this also fixed it, was that we were unintentionally, this is a little bit of a foot gun with Rust, is that sometimes these things that are untyped get set as references, and sometimes they're not. And that can get you can get a little confused by that. Anyways, this ended up being a reference being passed in from self, because self itself was a reference. And so then we were calling mem transmute on the reference rather than the underlying data.
And so you were getting the pointer value as opposed to the value of the thing pointed to.
Correct. So we were hashing the pointers of the F6 of the 64 of the doubles. And this was okay, because in a hash map, what happens is if things hash together, you just get a collision, and then the hash map then becomes a linear walk of that same, bucket. And so it was somewhat, and in fact, this was manifesting in one of the tests that was like stressing hash maps, which I think was going after GC, some other GC bug in the Wren C, was actually triggering this. And that sometimes it would fail and sometimes it would pass. But now it passes all the time. Because
and you found this with profiling, like with the tools we were using last episode?
Yes, so I found this with profiling, and this actually I was kind of proud of myself. It leaned on some past experience, but it was profiling like some number hash or something like that. Anyways, and this is why. Remember we said there was one test in our profiler that just took minutes to run.
Yeah, you had disabled it because it would just would not complete running.
Well, that was why. Is that what would happen?
Oh, this was why?
This was,
oh, wow.
I mean, I haven't actually gone to turn it back on, but I think I know what that test does. And I'm pretty sure that this is why. Because what was happening is that there was 2 bugs. One was that when I finally got to this, null, if you ever had a null in your map, it would recurse infinitely and crash the stack. So that was a bug. But this one was making numbers that occupied the same location in memory all hashed the same.
And so if you were just like had a stack where the top element was the one you were operating on all the time, it was often in the same location in memory or something.
I think it was this GC test case where what it was doing was it kept setting something and then setting that in the.
Oh, I see.
So it kept like setting a field and then setting that field in the hash map, or something to that effect. But anyways, it was causing the same number or the same like location on the stack in the Wren program, and the stack is just a vector, and so that same value was just getting hashed and hashed and hashed and hashed and hashed. And so it was triggering linear lookups in your.
This is really your only use of unsafe in the whole program?
This is the only use of unsafe in the whole program. At least the only one where I typed the word unsafe. Libraries obviously do it, here and there. I'm pretty sure unsafe. VM.
Yeah, that's really cool.
So now I actually don't know. I mean, I've avoided writing a GC for this. In part because I think it would be like the GC is not actually that much code in Wren C. For the GC itself, all the code is tracking down all the places where you need to push something onto the roots. The roots are the things that the GC knows to walk from. Because otherwise, if you have things on the C stack, the GC might not know that they're there, and it might collect them.
That's probably easier in Rust because you can have a fancy type that's like, I'm a GC root or whatever.
Well, actually, my handle thing, right? Mm-hmm. My current handle type, if I just always have these GCable objects inside handles, which is what JavaScript core did, at least when I hacked on it, 20 years ago, that can mitigate that kind of thing, to have a smart type in C++ or Rust. I realize I'm not looking at the camera. I'm looking at you on my second screen. So
if we try to move up to the parser, we're going to hit the VM initialization issue.
Well, I mean, I think we could fight our way through that because I think I was really close.
Okay, let's try it. I mean, I felt like it was finding a crashing bug in your code, so like that seems like at least a place to look at.
That crashing bug was a result of me trying to fix it because again, I wrote all the code, so it was leaking. I don't know, some thousands of objects, and right before the show, I was trying to hack it together to see if I could get past it so we could fuzz the real thing, and I got it down so it was only leaking 17 objects. And then I got this crashing bug.
Yeah, I mean, this is another source of like it's not the unsafe keyword, but it's another source of crashes or unexpected behavior. Is you have a lot of reference cells that you then pull mutable pointers out of, which is fine. The type system hasn't proven that it's okay, because if you try to do that twice at once, then it'll get mad at you because you're trying to take two mutable references to the same thing.
So like if we turn that one on, we're hacking up our. If I knew how to use this fuzzing library, clearly you could have multiple targets. I did not before the show, but this makes me want to. Rust has so many things for me. It clearly was written with me in mind.
Well, part of what I'm amazed at is when we started this project, it wasn't that many weeks ago. You had like not written a Rust program at all.
Oh no!
And I feel like you're now up to like fully working full speed like Rust development, which is cool.
I could go take a job doing Rust. But
your DMs are open, as they say.
No, I'm not looking for a job. But no, so my job honestly is to mentor people these days. With various managers working for me, and I do a lot of mentoring both inside Google and outside Google. But one of the things I commonly tell the people is just to, and something you commonly tell me, is to just chase the things that they enjoy. And so I've enjoyed working on this, and thus through it, I've learned a ton of Rust.
It clearly speaks to you. Like I think it speaks to me too. I think for much the same reason is that like I spent most of my career writing C++, and so when I go to a language like Java, I feel like I'm wearing these oven mitts because I know that it's like I know what it's doing under the covers, and I'm like I don't need to do all that. But when I use Rust, I don't feel like I'm using oven mitts. I feel like I'm just like there's like guide rails that are like keeping me where I want to be.
I will say the Rust learning curve is relatively terrible. They've clearly invested in it. Oh, we leave our Did we leave it?
But it's hard. Like yeah. It's just more complicated because like in Java, you have string, and that's your string class. In Rust, you have string and stir, and then you have C string and C stir, and like you have to like worry about all these things. And it's like, oh, okay. And then you have byte slices, which are not the same.
There's been various languages over the years that have spoken to me. Objective-C was one. Dart was another. Honestly, once I sort of got past the initial FUD around it. Python was another. Java and I never really got along, despite it being one of the first languages I ever learned. Okay, so
yeah.
So this is in VM clear class. We call clear class again. Really?
Is this like the cycle you're talking about between object and class?
It might be. Why do we? So clear class. We take the class and we borrow it mutably and we clear it.
Okay.
What I just don't understand is,
can you move it out of the reference cell before calling other things? So then when they come back to you, you'll be an empty reference cell as opposed to be.
Well, that's what the pattern is supposed to do.
Oh, maybe you're still borrowing the cell. You have to like give the cell back. Like take the thing out, get rid of the mutable reference, and then do the recursion.
So you're saying if I just did this?
No,
or you're saying inside clear class?
Let's look inside clear class.
Because this is what I'm trying to do with take, right? I'm trying to null out my thing so that to avoid exactly this class of recursion.
Yeah, this reminds me in like when you write a ref pointer, especially in C++, you do this trick in the destructor where you first pull the pointer out, you null out the pointer, and then you call the destructor to prevent. It's a very similar kind of issue. Yeah, so here, can you pull the thing out of the cell and then call clear on it?
I mean, I could do something like if maybe class is none, return. And otherwise, let class equals. I don't know if this is kosher or not.
I don't have the editor today, but I don't mean to like. I don't think that's going to help you.
Oh, I see. You wanted
to. Imagine like you swapped it onto the stack and then you call clear on it. Like, does a so what does it type here? It's a handle. Handle's an RC. Does RC have a take?
Oh, good question. That's really.
You just want to get it out of the cell so that when someone else goes and finds it, the cell is empty.
How do I make a
get mutt? So get mutt. This. Yeah, I want to like into
unwrap failed. Why is unwrap failed? How is that possible? Already borrowed.
Yeah, you've already borrowed. That's the issue. I think you can do it with swap. So if you make an instance of your thing on the stack, like make a class obj or an obj class local.
Oh.
Yeah, and make it mutable. You don't have to say none. Just say let mutt local. Yeah, and then say std mem swap.
Yep.
And then mutably borrow your local thing, and then also call borrow mutt. Yeah. You have to mutably borrow the opt class.
To like, how so?
It's like ampersand.
Oh, that's
The problem with your ref cell is not like, what does it have in it now? Like it's got to.
I don't know. Like, can ref cells be empty in that way?
No, they can't really. Can you want to like destroy the ref cell? Yeah, like how do you destroy a ref cell?
Like, take the thing out of the ref cell?
Mm-hmm.
I just don't know. I need to get a browser window working here.
Yeah, ask the internet. Let's see.
All right. Okay. I have a take.
Oh, it has a take? Oh, okay. Yeah, try to take it.
It may not have a default, but sure. Do we just borrow and then take it?
I think you just take it. Just say obj_class.take.clear.
Okay. Obj class dot. Oh, we don't need an obj class here. We just need class, right?
Class. Like, is your handle is a combination of an RC and a ref cell, right?
Sure.
Okay. See if that compiles.
Pardon our sticks and what do we got here?
They need a default. Can you define a default that's harmless
For
your object class struct? Because it wants to give it to you, right? But it's saying, what am I going to put in its place?
mm-hmm.
It wants to put in its place a default initialization of your thing.
Sure. You can define an object class default. Like, I laugh, but like, this is how programming was when when I started 20 years ago, which feels like
I know it now just feels like, oh, where is anything? You can just maybe derive default out of this. This thing looks like perfectly defaultable.
This is defaultable.
Yeah.
Oh, it totally looks defaultable. Oh, actually, I don't even need to type this manually. Okay, I do. There we go. Still have Visual Studio Code shortcuts or whatever.
Oh, there you go.
It worked.
Let's see if the fuzzer is happier.
Everyone's holding their breath.
It's thinking real hard. I really wonder what it's thinking about. Like the amount of computing power it's able to like apply in that amount of time is just astronomical. Like it could like solve several chess games. Like,
cool. Look, I think we're off to the races, sir.
Oh, it's going.
This is fantastic. Yeah. So this is what I was. This is a really big deal. So this is what I was trying to get us to, and I just didn't quite get there before the show, because last night when I first ran this, it just crashed with like 1,000 or a couple thousand objects leaked, and I was like, oh man, I got to tear down all the refs. And so then I built this whole system to tear them down. The patch isn't huge, but I basically had to teach all objects the like obj trait that we had, how to drop all the references.
Yeah, I mean, it's sort of a hack, right? Like it's be way better to have an actual garbage collection, but at least it lets you get to this, right?
I'm actually first of all, I'm really impressed that we haven't crashed yet. That would actually make me. Also, we're only doing. There we go.
Oh, it found something. That's cool. Okay, so now this is interesting, right? Before it either found something immediately or ran for a long time and did nothing. Now it ran for a long time and found something.
Num bitwise shift right. So this is exactly what fuzzers do.
Okay, can we look at the input that caused this?
This is exactly.
This is cool that this found it like an interesting bug that we didn't artificially put there.
Yeah. Man, the demo gods are with us tonight. There you go.
Okay,
Okay.
so you try to shift
So-
some numbers, some
Now I
crazy,
wanna do
crazy
this.
numbers.
Right?
It's going to minimize it.
Yeah.
Okay. So it's just like dancing around the crash. Like, did I still crash there? Did I not?
Oh man.
So this is the minimized artifact?
We are living in the future.
That's so awesome. Look at that. See, it took this like garbage thing. I was like, what is that? So if you try to shift right by 101, then
panic.
No good. But like, what is this panic?
I just don't understand. I don't know that I can like express the joy. This is such cool technology.
Well, it's a really powerful tool, right? This is a big, complicated program that clearly it like thought a lot about, and it found something. Like, can we look at the bug? Like, I'm really curious what this bug is.
Is it bitwise? Oh, I know my bitwise shift right was with a hack.
Oh, it was a dirty hack, huh? And the fuzzer's going to call you on it.
Maybe not. Actually, oh, this is just Rust. We just call shift right from Rust. I wonder what Wren's behavior is here.
So what's wrong about shifting right by 101? Like that seems like a perfectly rational thing to do. Like you just get 0.
Well, it's going to be bigger than the number. Shift right's going to just go to 0. It depends on what the defined behavior is. Are we a rotating shift? Like I don't know what SHR is defined as. So let's see what our panic actually looks like.
Yeah, what does the panic actually look like? Sorry, I live for this stuff. This is like.
Oh yes, we may have made a career out of it. Oh my god, I love that the minimizer is built in. Like I remember when when Abhishek down the hall was like writing, a minimizer.
And first it was only a line-based minimizer, and like this thing is like a byte-based minimizer. Like it really.
And I literally just installed a cargo crate, last night.
We're gushing, but let's look at the crash.
Yeah.
Okay. Deadly signal. Okay.
Backtrace full, panicking, unwind.
Can we look at this? Like why? Like it's
panic and attempt to shift right with overflow. Okay.
I see. So probably Rust is like you're trying to do something sketchy.
Rust will panic when you subtract with overflow.
Yeah. So so we want to like somehow turn off the safeties and be like, we just want to. Or overflowing shift right. Oh, there you go. You're just using the wrong functions.
What does this even do?
Shift right? I think it just probably allows overflow and tells you whether you got it. And you'll just say, I don't care. That's
but this is where we have to actually look at what Wren does.
Can you run Wren C? Or like I guess there's the web version.
I have Wren C. Well, I don't have it built in. Given how far we are in the show, I think it may be time to swap pieces.
Oh, you got me on the edge of my seat, Eric. But this sounds like interesting, right? This is clearly like a real bug. That's quite interesting. It's like it's gonna be like I imagine you're gonna probably resolve it by using this unchecked or overflowing shift or whatever. But like it's a real bug. The first
thing is to check what Wren C does here, and if Wren C panics here too, then we have to pick a behavior.
Or we have to like catch the error and report a runtime error instead of crashing the VM.
Well, I think that's what it should do. Is it should be a runtime error. I'm like, no, we don't allow you to shift. I mean, I could try, but like, I really like.
Whatever. This is great. Like, I think we demonstrated the idea of what fuzzing is like and what it's like when you find a bug. Like, it's exciting.
Well, and the thing is, we now have a tool that's going to find us 1,000 of those.
Yeah, once you can run for like 5 minutes, you can let it run for an hour. Then you let it run overnight, and then you get a whole cluster of machines. Buy some like Google Cloud compute time and go nuts. Right?
Please sponsor our show.
But it depends on like the value of the thing, right? If it's like really important, like you're going to ship this to 1 million people, and you want to get it right, then you're going to spend
or 1 billion people,
or 1 billion people, or however many people it is, right? Going to spend the compute resources to find these subtle bugs.
Yeah. I have no idea how this is interesting to our viewers, but for me, this is like such a trip down memory lane and a lot of fun to play with this stuff.
I just think it's a useful tool. Like, it's a great tool.
I do like your suggestion of, I wonder what the world looks like when this is just like a thing that you have in Xcode, or like, why doesn't it
like the world changed so much when people just like adopted unit testing as a part of their software engineering culture. Like, just adopt fuzzing. Like, it's a really good tool.
And it's so close. It's so close. Anyways, before we let everyone go, we have been trying to, we're kind of over time, but we have been trying to do, tell us things you learned. What'd you learn this week, Dr. Barth?
I learned that tempfs in the Linux kernel is really clever.
Yeah.
So the Linux kernel has a bunch of caching mechanisms for basically speeding up file system accesses. Like, if you try to like open a file in a directory, it'll remember in memory that file exists in that directory and doesn't have to go back to disk to go find it again. And then what I learned is the way tempfs works is it only exists in those caches. So there is no like backing information that the cache is validated against. They just basically somehow, I don't know what the mechanism is, somehow arranged to not be evicted from the caches. And so the entire file system is just implemented in the cache. I thought that was really cool, like really clever idea.
Cool. Well, in terms of technical learnings, you got to see mine. I learned all about WSL. I learned all about Rust fuzzing. I think my non-technical learning this week was how important going to the office is for me.
You actually went to the office this week.
Oh yeah. It's amazing. Like, I don't enjoy the commute, but I will tell you the mental space is great. To like just have a block.
I'm leaving home. I'm going here. I'm in work mode.
Yeah, and to be around people again, to see people I hadn't seen in 15 months or longer. I don't even know. Oh, it was amazing. So I'm so glad that the world, at least around here, and I know that viewers in other countries, it is we got a long road as a world left for us with this virus, but at least around the Bay Area for this moment in time, things are opening up again, and it is really nice.
I hope it lasts.
I hope it lasts too. So anyways, it was wonderful to see you. It was fun doing some reminiscing, fuzzing with you. And next week, we should have done this at the top of the show.
No, it's a reward for the viewers who watch to the end of the show.
Yeah, if you got it this far. Next week, we will be doing an episode on
Fuchsia. We're doing the Fuchsia episode next week.
We're doing the Fuchsia episode next week.
We're going to talk about Fuchsia.
Yeah, we'll tweet all about it. But come, bring your party hats and champagne, and we'll be talking about Fuchsia. So
I look forward to it. See you next week.
See you next week.